project name is Spam Classification with Naive Bias and Support Vector Machines. We are here trying to compare the two classification algorithms that are the naive Bayes and support vector machines by trying to make a project that will filter the spam messages from our mail inbox or the message inboxes. Right, we have built a spam classifier program in Python, and we can we can do this by using a simple theorem from probability and bias there, and that is called as the bias theorem. And by support vector machine, we are going to find out which one is better, and by comparing both of these algorithms. And we are just simply importing the libraries that are going to be used for further in this project. And then the second thing that are going to be okay, first of all, let me show you some just that are we are going to do the summary of the tasks that are going to perform in this project. So we are going to import the libraries, then we are going to explore the data set. That means we have to import the .csv file that stores the tabular form data in other forms of commas, just when we import it, it can be uh, uh, it can be imported as in the form of tables, tabular form again. So, and the third gonna be the distribution of spam and non-spam plots. We are gonna plot the charts for that, different pie charts and bar charts. Then gonna be the text analysis. We're gonna do some analysis on the text. Then the feature engineering. Okay, we have not made the index, but this is all of the project actually, the 5 pages, and and the fourth one is going to be the predictive analysis. That is the multinomial naive Bayes and support vector machines, multinomial. And then the last one will be the conclusion about the project that we get out of it. And we were here just importing the libraries and needed for the project, and then we're gonna exploring the data. That means we're gonna import the file, and then there's gonna be the output. So it should be something like this when you load that spam.csv file. Then when you have to actually these values are not available, so we have to drop those columns from here, from that end, and we have to display all the data, rest of the data. That for that we use the msg.head, and it can now and then comes the bar, after removing the, and this is the output after removing the uh, 3 columns, and then distribution plots, right? So and this is the code, and I guess I should not have to go and explain the code, but just after applying these lines of code, you're gonna have the output such like this, similar to this, uh, and the these are just the simple codes that we are gonna be having. So these are just the output, and this so then the next topic is predictive analysis. uh, my goal is to predict if a new SMS is spam or not spam. I assume that is much worse misclassifier, non-spam, that misclassifier and spam. I don't want to have a false positives. You know, though in the IR file system that we have studied. So the reason is because I normally don't check the spam messages. The two possible situations are, the first could be the new spam message SMS in my inbox is a false negative. That means outcome is I could delete it, and a new non-spam SMS in my spam folder false positive. That is outcome I could probably don't read it. So I prefer the first option. First, we transform the variable spam, non-spam into binary variable. Then we split the data set in training set and test set. So spam is going to be the 1 and ham is going to be the 0. So if it's going to be spam, it's going to be mentioned as true, as in binary form. So we train the data, and this is what we get as a result of it. So then here comes the conclusion with the matrix. We misclassify 56 spam messages and treated as non-spam emails, whereas okay, so okay, sorry. We misclassify 56 is 56 is where is that? Okay, we misclassify 92 spam messages as non-emails, non-spam emails, whereas we don't classify any non-spam message. Okay, so support. Then we come to support vector machine, and we are going to apply the same reasoning, applying the support vector machine model with the Gaussian kernel. We train different models changing the regularization parameter C. We evaluate the accuracy, recall, and precision of the model with the test case. So this is the code for having the accuracy, recall, and the precision to calculate the accuracy and the different measures to define the quality of the algorithm. Which one is better to among the naive bias out of the support vector machines. Then later, confusion metrics with SVM classifier, the second last topic, and we and with that confuse by applying with that code of that lines of code, those lines of code, we misclassify 48 spam as non-spam messages, and whereas we don't misclassify any non-spam message. So sorry, that's wrong. Okay, we misclassify. I just want to repeat here. I just interpreted it wrong. That we misclassify 92 spam as non-spam messages, and whereas we misclassify one non-spam message as spam message. So this is a pretty good okay, not a really good theorem, but if we gonna change the percentage value of the failure or the success, it's quite low, I'd say. So, and the second one is that then comparing these results with them, that we misclassify 92 spam as non-spam messages, whereas we don't whereas we whereas 6 non-spam messages as the spam messages. So for that the final conclusion with that comes is the accuracy of support vector machine is 97%, 97.7%, and the accuracy of naive bias classifier is 97.5%. So the best model should be the support vector machines. So thank you for listening. Thank you. It was nice.